In this video, we're going to talk about long division and synthetic division of polynomials, but I want to first do an example with numbers so you can kind of see how it works. So I know some of you may not remember this way of doing long division, and then I'm going to talk about some of the vocabulary involved too. So I'm going to take 17 and divide it by 3. So the process is you say what times 3 will be less than or equal to 17, and that would be a 5. So 5 times 3 is 15, and so we subtract the 15 from the 17 and we get 2. Now let's name some of these parts here. So this thing, the 17, is called the dividend. So try that again. It's called the dividend. The 3 is called the divisor. The 5 up here is called the quotient. And then we're probably familiar with the 2 is known as the remainder. Now, there are 2 forms that we can write this result that will make it a true statement and summarize everything we have. One way is we could say 17, the dividend, is equal to the divisor 3 times the quotient 5 plus the remainder 2. And you can see the truth of that statement because 3 times 5 is 15 plus 2. A second way you can write this would be to write 17 divided by 5 is equal to the quotient, hold on there, 17 divided by 3 is equal to the quotient 5 and then plus the remainder 2 over what we divided by as a fraction. That is, we would call that 5 2/3. But this is going to be the way we think about it in terms of doing this with polynomials. So what we are going to be looking at is we're going to have a divisor of x minus some number. We're going to divide that into some polynomial, which I'm going to call not q of x there, but I'm going to call that p of x. So we're going to divide x minus r into p of x. We'll talk about what we have to do along the way there. We're going to get a remainder that we'll call r of x. It might be a number, it might be some actual polynomial, and then we'll call this the quotient q of x up here. So these are, again, the same things that we saw over on the other side with numbers, but then the 2 ways that we can write this information is we can say p of x, our original polynomial, the dividend, can be written as x minus r, the divisor, times q of x, the quotient, plus the remainder r of x. Or we could also sometimes write it in the other form, like we saw up above in the green. We could say p of x, our original polynomial, divided by x minus r will equal the q of x, our quotient, and then plus the remainder, whatever that turned out to be, divided by x minus r as a fraction, what we started with. So this is the idea. Let's see how this is going to actually work in practice. So I'm going to go to a new page because I want to I'm going to compare this synthetic division as well. So we're going to start with our long division. We're going to go x minus 3, and we're going to divide that into, and we have x to the 3rd minus 2x squared plus 3x minus 4. Now, you want to write this dividend inside in order from highest power to smallest. Sometimes there may be a missing term, like if there wasn't an x squared term, it might help your cause to fill in with like a 0 x squared, just so you have a column to put those terms in as it arises. Now we ask ourselves, we say what times x is going to be equal to x to the third, and that's going to go up on top here. And so we say x squared times x will be x to the third. So we multiply then the x squared by, we distribute it over the x minus 3. So that's going to give us x to the third, and then a minus 3 times x squared will be a minus 3x squared. Now remember, we're going to subtract this quantity, so you have to be careful and keep track of your negative signs. Now going down, the x squared minus, or the x cubed minus x cubed drops out. That was the whole purpose of that. The negative 2x squared minus negative 3x squared makes that a plus 3x squared and becomes, I'm going to change colors here so we can keep track of the different levels of this. And so that's going to give us just an x squared. I'll bring down the plus 3x and the minus 4, and we'll now repeat the process over again. So now we're asking ourselves, what times x is going to be x squared? And the answer to that will be a plus x. So now we're going to multiply the x times the x in x minus 3, and also multiply the x times the minus 3x, and that's going to give us an x squared minus 3x here. We remember that we're going to subtract that quantity, and so now the x squared minus x squared is going to drop out. The 3x minus the negative 3x makes that a plus 3x, and we get 6x minus 4. And so we repeat the process again. So now we ask ourselves, what times x will be 6x, and that's going to be a plus 6. And so the 6 times the x will be 6x. The 6 times the negative 3 is going to be a minus 18. We remember that we're subtracting this quantity, so the 6x minus 6x disappears, and we're going to get negative 4 minus the negative 18 makes that a plus 18, and so negative 4 plus 18 is going to be 14. Now, once our remainder is a degree smaller than the divisor, that's how we know that we're finished. Now, the two ways that we can write this are, we can say our original p of x cubed minus 2x squared plus 3x minus 4 is equal to our divisor x minus 3 times the quotient x squared plus x plus 6, and then plus the remainder, which is 14. And the other way we can write this is to say x to the third minus 2x squared plus 3x minus 4. That's our original polynomial, divided by the x minus 3 is going to be our quotient, x squared plus x plus 6, and then we'll take our remainder, 14, over what we divided by the x minus 3. Those are the two ways that we can write this result. Now, one thing to notice that I want to point out right here, and we're going to call this the remainder theorem. The remainder theorem. When you look at this version of our polynomial, you can see if I call this p of x on the left, and what we have here on the right is exactly equal to that. We have equality. So if we were to evaluate this polynomial, this p of x, if we were to evaluate that at 3, that is what would make this divisor 0, p of 3, then that would become 3 minus 3 is 0. That would wipe out all of this stuff, and it would be 14. Now that 14, remember, came from the remainder. So our remainder theorem takes note of that fact. That's not a coincidence. That's going to be true all the time. So we're going to say if a polynomial p of x, this is our remainder theorem, if a polynomial p of x is divided by x minus k, then the remainder remainder r is going to be exactly p of k. Okay? So let's now, I'm going to leave this up here, and now I'm going to show you an alternate way of doing this division. We're going to need to know both, but this, what that we've just done, is known as long division. And now I'm going to show you synthetic division. So synthetic division is going to work something like this. I'm going to take the coefficients of that original polynomial, that is the x cubed minus 2x squared plus 3x plus 1. And I'm just going to write the coefficients in order. 1, negative 2, 3, negative 4. I'm going to leave a little space underneath because I'm going to put some more numbers under there in a moment. And then in a box on the left, I'm going to plug in what will make this 0. That is, we're thinking of this like we did in our remainder theorem as x minus k. We're going to plug in just that k, the 3. Okay, so this is our setup for synthetic division. The coefficients go across the top. The divisor, the what we would call the 0, if that went in there evenly. So in our factor x minus 3, that's going to be a 3. If this had been an x plus 2, we would have written a negative 2 in the box. Now I'm going to add down the first column and bring the 1 straight down below the line. Then I'm going to multiply what's below the line by the 3 that's in the box and write that in the next column underneath that number there. Then I'm going to add down again. The negative 2 plus 3 is 1. And I'm going to take that number below the line, this 1, and multiply it again by that 3, and that's going to give me another 3 there. I'm going to add down, and that's going to be 6 below the line. That 6 gets multiplied by the 3 in the box again, and I'm getting 18. We add down, and we get 14 here. Now, those numbers probably look familiar. They should be. This 14 is exactly our remainder. And remember, we said earlier from the remainder theorem that, if I can get my pen to cooperate here, that means that our polynomial evaluated at 3 is equal to 4. Now, if all we use is that number there, like we did here, this we would say that what we just did was synthetic substitution. But it's better than that. There's more. So if you notice that these numbers in here are exactly the same as our coefficients in our long division that we did way up here in the beginning. Let's see, I can't get to there. So it's going to be these coefficients up here in our quotient. So we divided, remember our original polynomial was an x to the third. So this is telling us we're going to have 1, and then we're going to go down in the power of x. 1x squared plus x plus 6. That's exactly our quotient. So we can say then, if we like, our original polynomial is that x minus 3. And then we can see where we got the x squared plus x plus 6, and then our remainder of 14. Whoops, I think I called that 4. It should have been a 14. Let me fix it now. Okay, let's see if we can do another example here and see if we can clarify this. Let's do synthetic division here, and we are going to talk about x plus 2. This is the setup as if it was long division. So I'm going to say 2x cubed plus 5x, and then a minus 4. So there's our long division. And so I'll come back and do this using long division and see that we get the same thing. But let's do it first using synthetic division. So I'm going to put in the box what would make this be 0. So that's going to be a negative 2. I'm going to write in order the coefficients of this polynomial. But notice we're missing an x squared term. So 2 is going to be the coefficient of x to the third. Since there is no x squared term, its coefficient is 0. I absolutely have to put that in there. Then I'm going to go 5 for the x and a negative 4 for the constant. I'm going to leave a space, and I'm going to draw this line. Now, the way we do this is the first number comes straight down below the line. Once it's below the line, it gets multiplied by what's in the box, and that's going to be a negative 4, and that goes into the next column. We add down and get a negative 4. Once it's below the line, it gets multiplied by what's in the box. That's going to become 8. We add down. That's now going to be 13. Once it's below the line, we multiply by what's in the box. That's going to be a negative 26. And we add down and get negative 30. Now we have all kinds of information here. We could say our polynomial evaluated at negative 2 is equal to that negative 30. That's one piece of information. We can do more. We can say our original polynomial, p of x, I'm just going to call it p of x instead of writing out the 2x to the third plus 5x minus 4. That's equal to x plus 2. That was our divisor. And now I'm going to pick up these coefficients. We're going to go down 1 in powers of x. So that first 2 is going to be a 2x squared. And then we're going to go down in powers, minus 4x plus 13. And then our remainder is that minus 30. Now let's see if we don't get the same thing doing long division. So I'm going to rewrite this x plus 2, and I'm going to, kind of like what I did with the synthetic division, I'm going to put a placeholder where I'm missing that x squared term. So I'm going to call that 0x squared plus 5x minus 4. So to do this, remember, I'm going to say what times the x is 2x cubed. That's going to be a oops, let me erase that. Let's call that 2x squared. So 2x squared times x is going to be 2x to the third. 2x squared times the 2 is going to be 4x squared. I'm going to remember that I'm going to subtract these two things. And so the 0x squared minus 4x squared is a negative 4x squared. Now I'm going to bring the rest of it down, the plus 5x, the minus 4, and we're going to do this again. What times x is going to be a negative 4x squared, and that will be a negative 4x. The negative 4x times the x is negative 4x squared. The negative 4x times the 2 is a negative 8x. We're going to subtract that quantity. So the negative 4x squared minus the negative 4x squared will drop out. That was by design. The 5x minus negative 8x makes that a plus 8x, and that becomes 13x, and I'm going to bring the minus 4 down. We repeat one more time, and we say what times x is 13x. That's going to be a plus 13. That's going to give us 13 times x is 13x. 13 times 2 is 26, and we're going to subtract that quantity, and the negative 4 minus 26 is negative 30. And so you can see we have the same numbers here. We're going to get that same result. Here is our quotient, which exactly matches our quotient there. And here is our remainder, which exactly matches the remainder there. Okay, I'm going to stop here for this video, but we'll explore this a little further on the next one.